So distribution, or sometimes referred to as frequency distribution, describes how a variable is distributed. Okay, variable in this case meaning something like the products. How does it change from day to day? Before we move on to the products, let's take an example. So if you imagine measuring temperatures in some location in the UK over a year, you might expect the values to lie somewhere between 5 and 25 degrees. Okay, we don't tend to get very hot weather in the UK. We don't often get very cold weather, but you might find that the values are somewhere between that, with an average of maybe 15. I don't know if that's accurate. I'm just making these numbers up, but it'll be something like that. It might be higher than that, might be a bit lower. Occasionally, we get extreme weather, what we call extreme weather, where perhaps goes down to -2, or maybe goes up to 32, 34, 35 sometimes. But mostly, it'll be within those bands. But if you go to other parts of the world, obviously you get different sets of distributions. So California is well known for having a very even temperature throughout the year. So the values might, again, I'm making these numbers up, but you can imagine the numbers might lie somewhere between 20 and 30, with perhaps an average of 25, and occasional extremes going up to perhaps 35 or down to 15. But they don't often get very cold, frosty weather in California. I made these numbers up, but you get the idea. The distribution of these values is different depending on which parts of the world you go to. If you go to a very hot place, obviously the average might be much lower, but the extremes might be less extreme. They might be more extreme. If you go to one of the poles, then you'll get the opposite effect. Okay, so statistics has a way of describing the spread of values, which is called the standard deviation. And for the UK, the standard deviation would be something like 5, and for California, it would be closer to 2.5. Okay, so it's describing how spread out from the average they are. That assumes the data is normally distributed, which often it is. So normally just means that you get a kind of a normal shaped curve of most of the values being in the middle with some outliers on either side. It's a technical term with a very specific meaning, actually, but people tend to use it fairly loosely. It just means typically most of the values are kind of clustered around the middle. Something that wasn't normal might have all the values at one end and all the values at the other end, okay, and very few in the middle. You'd still get an average in the middle, but all the values would be at either end. That's not normal. Most of our data tends to be normally distributed, so most of the values are sort of averaged in the middle with a few outliers at either side. And if that's the case, when you're talking about normal distribution, if you say if your data is normally distributed, and then what that means is, what the standard deviation means is that 68% of the measurements will be within one standard deviation of the mean, and 95% will be within 2 standard deviations. So if you think about the UK, if the mean is 15 and the standard deviation is 5, then 95% of all measurements are in the 5 to 25 range. Okay, so 5 plus 2 standard deviations, 15 plus 2 standard deviations is 25. 15 minus 2 standard deviations is 5. So 95% of those values, if you've got a normal distribution, 95% of those values are going to be between those two things. Think about California. The mean is 25. The standard deviation is 2.5. Then 95% of the values will be in the 20 to 30 range. Okay, this is and then anything beyond that is known as an outlier. So extreme values outside the 2 standard deviations are known as outliers. There's no standard statistical definition that I could come up with, but it's described in, if you want to look it up as how Matplotlib thinks of them, then have a look at that webpage. Okay, so that's a statistical way of describing how much the data is spread out, but we're doing visualization, right? Not statistics. So there are 2 standard ways of visualizing distributions. Actually, there's a number, but we're going to look at 2 of them. we're visualizing distributions, deviations, and outliers. And each one has their own advantages. And the two we're going to look at are histograms and box plots. Okay, so a histogram, it shows frequencies that that values appear using a set of bins. Okay, so if you think about the UK data, you sort the data. So we've got this collection of temperatures. Maybe throughout the whole year, we've got a collection of temperatures. We sort them out and we put them in a bin. So if we've got a temperature of 23.7, it would be put in the bin that goes between 22 and 24. If it's, I don't know, 25.8, it would go in the bin that goes between 24 and 26. So you set a range of values by these bins, 20 to 22, 22 to 24, 24 to 26. And then you sort all your values and put them in the different bins. You don't do it, obviously, well, you could, but much easier if you can get the computer to do that for you. Then you count up the number of values in each bin and visualize it as a bar with a height representing the number of values in the bin. So if you look at this is why some people sometimes use the term histograms when they mean bar charts, and sometimes they use bar charts when they mean histograms. They're not the same thing, because histograms measure frequency. Okay, so frequency is it's the number of values in each bin. And so if we look at those two examples I've given you, UK and California, what you'd expect to see is something like this. So again, this is just made up data, right? But it's kind of based on the values I've given you. You'd expect to see something like this, where the UK temperatures are much more spread out, but the California temperatures are much closer together. But both of those are kind of normal distributions, because the curve kind of goes like that. So they look kind of normal to me. And that then begs the question, well, how big should the bins be? You know, I've chosen bins of size 2 here, so anything, you know, between 20 and 22 goes in one bin. Obviously, if you have too few bins, then the visualization is pointless. So if I just had a bin that went from 0 to 30, almost everything in the UK and almost everything in the California temperatures would go in that one bin, and so the histogram wouldn't tell us very much. It would look like that, in fact. So very little. You can't even tell whether that's a normal distribution. On the other hand, if you go the other way and have lots of tiny bins, then that also is of limited use. You end up with something like this, where essentially you end up with just a few values in each bin. So I think the most you see there is in the UK is 5 values in bins, because they're all too narrow. The bin width is 0.1, so you're only getting 5 values in a bin maximum, and mostly it's just 1. So choosing the number of bins is important, but there's no correct number of bins, and usually you'd need to experiment with this to determine what's appropriate for your data. Usually you don't want too many, you don't want too few, and usually somewhere between 10 and 50 is a good number. Okay, that's histograms, and we can let matplotlib to decide how many bins. We don't have to choose that number ourselves at all. So we could just let matplotlib decide. Or we'll see in some examples, we can tell it how many bins to create. Like we want 10 bins or we want 50 bins, and then it would decide where the boundaries go. Or we can be more precise about where the bins start and where the bins end. So this is the code that I use in most of the examples, most of the histogram examples. So this is my bit of code, or this is the bit that I can change. So I decide where the lowest edge of the bin is and where the highest one is, and then the width of the bin. Okay, so you can then see, obviously, if it goes from 0 to 40 and the width is 2, there's going to be 20 bins, and so that will get calculated. Actually, I think it's one more than that. That gets calculated here. No, sorry, it is 20 bins. It gets calculated here and printed out, and then it creates. Then this code creates the bins. So you don't need to bother with this bit unless you're interested in the programming aspects of things. This bit will calculate the bins for you. You just need to decide what these values are. Where's the lowest value, where's the highest value, and what width are the bins. If I set that to 20, then I'd only get 2 bins. If I set it to 1, I get 40 bins. So you've got to decide, what's this is a kind of crucial parameter, the bin width. What's a good width of bins to get that kind of normal distribution in the output. Of course, you might not get a normal distribution. It depends what the data is doing. If you don't get a normal one, that's telling you something else about the data. Okay, so that's the idea of histograms. We'll go and apply them in the next video.